Here are two additional examples. Now this one here is sodium hydroxide. Now the cool thing with this is it has this thing, a hydroxide, which we just bonded. Hydroxides are always bonded the exact same way, okay? So a hydrogen has to bond to this one. Now, on the previous example, I had it bond to this single electron. Really doesn't matter. Remember, these atoms are rotating anyway. So just because it's a single at the 6 o'clock position here, I'm not really going to spin the page, but I could spin the page so that the single electron is at 3 o'clock and 6 o'clock if I really wanted to. Now, normally what happened is I had an extra electron go there, right? Well, in this case, remember that sodium is a metal. It's going to give up its electrons. It's not going to form a covalent bond. So this electron at sodium is going to come right over here, and I'm going to show it with an arrow because sodium is actually going to lose the electron. When that happens, sodium is going to become a positive ion. We have oxygen. Like that. It's going to have a hydrogen attached to it, and then has this extra electron from sodium. And then it's an ion, so it's a -1 charge. Okay? Now, intramolecular bond, how this whole thing was bonded together, I have a polar covalent bond. I'm not going to do the difference in electronegativity because I just did it on the previous example. But I have a polar covalent bond here, and I also have an ionic bond. So there are two intramolecular bonds that bond this whole thing together. Structural diagram is similar, +1. I'll do the O first on this example. -1, so there'd be an ionic bond there. And we already know that this is going to be slightly negative, and this side would be slightly positive because of the previous example. And that's how that one would go. Okay? This bottom one, this is complicated. This is a sulfate ion. You know that from your nomenclature. So I also need 2 extra electrons that are going to come into play somewhere, right? And they are because of this -2 charge. Now, I'm not going to do the electrons to the very, very end. So what I can see happening is I can see this one hooking up here. And let's say this one is going to hook up here. Okay? Now, I'm going to give you a couple of examples of common mistakes I make, or not that I make, but other people make that I see all the time. And I'll explain why they're wrong in a minute. But I'm going to show you the right way here. So what's going to happen next is, remember, sulfur is one of those examples with some exceptions for valences. So sulfur can have 8 electrons around it. It can have 10. That would be if it had a valence of 4. And sulfur can also have 12 electrons around it. Now, what I'm going to do here is I am going to hook these two up as a double bond. That's kind of radical. And then this one is going to hook up there. And this one is going to hook up there. Now that's pretty complicated for a game plan. And then the last thing we have to do is this one is going to go right there. And this extra electron is going to go there so that everything is paired up. Now you might be able to come up with that, but most students have trouble drawing this. So again, I am starting with sulfur, which is kind of the central atom here. So I'm going to put sulfur like I normally would, 6 electrons around it. And then I'm going to do this oxygen here. Now you'll notice that I left a single electron at the bottom. You can have the single electron at 9 o'clock. You could have the single electron at 3 o'clock. It really doesn't matter. I'm just doing that. It's easier to draw that way. And then over here, same deal. You can have the single electron anywhere. I'm going to have it at the end. The important thing is oxygen had 6 electrons, right? 1, 2, 3, 4, 5, 6. So I'm still drawing oxygen with its original 6 electrons. Now, I do know that there's going to be an extra electron there and an extra electron there. Okay? Now up at the top, we had a double bond forming. So there's how I draw my double bond. Oxygen. Now this oxygen here formed this double bond. I still have these pair of electrons to draw and these two. So a grade 11 student would probably do something like that. Okay? Now this one is also going to form a double bond at 3 o'clock. Now again, I have two other pairs of electrons that I have to draw. Really, these are how they would be spaced out. Is almost at 120 degrees from each other. Again, for grade 11, I'm not really going to complain one way or the other or grade you better showing me one way or the other. I'm still going to do square brackets around it and a -2 charge. Oxygen has an electronegativity of 3.5. Sulfur is 2.5, which gives me a difference of 1, which is a polar covalent bond. So that means oxygen is slightly negative, sulfur is slightly positive. When I draw a structural diagram for this, sulfur, there's a double bond oxygen on the top, a double bond oxygen on the side, a single and a single there. It's an ion, square brackets, -2 charge. And then the final thing I have to do, the oxygens are slightly negative. Oops, that's supposed to be a negative, sorry guys. And this is going to be a slightly positive. And that's what it would look like. Okay, that's sulfate.